Hello everyone, this is me, Ibrahim Absalam. In this video, I will show you how to use Eagle to draw your PCB design. First, we open the Eagle program. We just simply download it from Eagle website and just run in a free version. It's enough. You can build 10 centimeter by 10 centimeter board, so I think it's more than enough for this training. Now, new schematic. We will build a 5 voltage power supply, so we'll have an AC input come from step down transformer from 220 voltage AC to 6 voltage AC. Then we'll add a diode rectifier followed by capacitor, voltage regulator, small capacitor, and output. Okay, I will estimate that the transformer is outside the PCB, so I will need a connector. From the add menu, here is it. It's called con BTR 500. As you can see, this is the connector I will use. It has 2 holes and 2 screws to add our devices. So this is the input terminals, and this is output terminal. I press add again. I will need the rectifier bridge. I just right click. Here is it. I have the half amp rectifier bridge, a small one, circle one. Here's it. Okay, you can rotate your component by right click. As you can see here, it's rotate. I just make the diode locks out so I can recognize the AC terminals and DC terminals. Then I will need a capacitor from RCL, C pole EU. It's mean polarized capacitor. I just go for one and until I found a suitable one. And then I will need a voltage regulator or one more non-polarized capacitor. This is the one I need. Finally, I need the voltage regulator. And here's it. Okay. Sorry, I select the wrong one. I need 7/8 voltage regulator. Here's this is 7/9. This is 7/8. That's the one I need. So I'll use the delete tool to remove this one. Now we need to write the values of the components. Here is it. You can write the name, the value. This one will be 7805. This one is 2200 microfarad, and this is a small capacitor, 0.1 microfarad. Now we can write a name here, AC1. And here DC out. We need to name, let's say it's ACN. Now we will use the net tool to connect our elements. That's it. Very nice. And the DC go to the capacitor, and this one go here. This is the ground, and this is the input, and this is the out. Okay. Now we finished drawing our schematic. We'll go to the board, switch to board, just press yes. Oh, first we save our project, save. We'll give it a suitable place and name. Let's new folder, PCB, and give it name 5 voltage power. Now switch to save it. Switch to schematic, from schematic to board. Here is the component we have. We just need to move our component to a suitable place. We'll use the move tool. This is the DC out, AC input. This is a capacitor, rectifier bridge, voltage regulator, and here is the small capacitor. Usually my advice I used to say before do even the net connection or your schematic connection, make sure that the component will fit the PCB if you don't know exactly what you have. For example, this capacitor looks big, so just once you select the schematic component, the component is schematic, before drawing the network, to transfer to schematic and print it using printer, and make sure that your component will fit. This is very important note, our advice, our trick I used to do. Now let's adapt the grid. The unit will be millimeter. If you want to display the grid, it will be nice for you if you like to see it and know how your traces work. Adapt the resolution of 0.1 millimeter is fine, so it will be more easy. Route tool. Now the width of the wire you will use 0.8 millimeter is fine for this project. And now usually this allow you to have 90 degree. This is 45 degree. In PCB it depends, but usually we prefer to use 45 degree. Now use this tool to connect your elements. It's about art more than engineering. This part looks missing. I just need to make sure that I connected in the schematic. Now I need to connect it here. To solve this problem, I may rotate this just to make my wires looks nice. Okay, now we finish routing our PCB. We need to add the copper filling. Just resize everything to make it suitable in size. You can add fixing holes. I used to add 4 fixing holes here. So if you want to fix it, it will be nice. Now we have, before adding the copper filling, we need to rename this track ground. So once we have the copper filling, we can connect this the ground to the copper filling. Double click here, we'll call it ground. Also we name this ground. Ground. Now I will use the polygon tool to draw the polygon. Before I need to select the isolation layer, usually I make it same as wire widths, or it depends on your design. Just draw it. Delete the extra. Now I will use this rat nest to connect everything. Here's it. Now the filling has done, but it's not connected to the ground, I need to rename this part. Double click here. I'll call it ground. You see here now everything is connected to the ground. This is better than for noise immunity and better operation of your PCB. So GRN. Okay. Now we finish our design. We need to send it to the PCB manufacturer or supplier. There's two types of PCB suppliers. Some of them you can send for them the Eagle design direct and they print it for you. And most of suppliers need the Gerber file. How we can create the Gerber file? First we save our work, then go from file, can process. Usually most suppliers use Gerber RS274X, and you build it for layer by layer. Let's say you build the job for the button, so you need the button and pads. That's Gerber, and one more for the top, and keep doing these steps until you finish. This process takes much time, so we used to do a fixed job, or we build a job. I will add the link in the button. We'll open job. No, it's here. I'll just trace where I save it. With the job, you can see here I add the top cover, top silk screen, button silk screen, top solder, and everything, and just simply process job. Now Eagle finished building the Gerber file. We first, before sending these files to the PCB factory, we just need to have a quick look. I will use Gerber Logics to see it. Open. I'll go. The Gerbers usually saved in the same folder as you save your PCB. Here's power supply. This is the PCB port, and this is the Gerber file. So I just simply drag and drop it here. Okay, we can see here this is the bottom layer, this is the pads via silk screen down, and the holes, so everything looks fine. You just simply zip it and send it to the PCB factor, and you'll get your design. Hope you enjoy this video, and bye bye.